take a look at finding the domain of each function. So we talked about finding a domain in range before when we were looking at just like ordered pairs. But here we have just the function, and we want to understand how to find domain of just in the function notation. So what we want to really understand is domain. Domain is the x values, right? So if I were to just think about just a simple graph, let's just look at a graph here of just a line. So if I had a line, and I'm thinking about, well, what x values does this line exist? So if I were to go to like x equal to 1, am I somewhere on this line? Yeah, I'm right here. What about x equals to like 10? I'm right here. What about x equal to 100? I'm right here. X equal to 1,000? I'm right here. So this line just goes on forever and ever in the positive direction. What about in the negative direction? If I'm at x equal to -1, I have a y value. If I'm at x equal to -10, I'm at a y value. X equal to -100, I'm at a y value. This line just keeps on going forever and ever. So the domain is all the x values. I can find an infinite amount of x values along this line because it just keeps on going forever and ever and ever in both directions. So the domain for something like this, with just like a straight line, would be from -infinity to +infinity. It goes forever in the negative direction and it goes forever in the positive direction. So any x value that I could think of, I'll have a corresponding y value along that line. That's what we're trying to think about here. That's what we're trying to put down as the domain. We want to identify where all the x values. So let's look at letter A. F of x equals 1 over x. So first of all, this is not going to be a straight line because I'm dividing by x like this. Let's just do letter B first. Letter B is 3x plus 5. We know that's just a straight line. 3x plus 5, y-intercept, we have the slope. If I were to graph this, you start at 5, up 3, over 1, up 3, and it'll just go on forever and ever. So the domain on a problem like 3x plus 5, there is no issues with the domain, so that's going to go from -infinity to infinity. My infinity signs aren't the best. Let me fix that a little bit. So the domain, it exists everywhere. Because there's no sort of like gap or problem with the x value. Like there's no x value that I could plug in that's going to cause some sort of issue. The graph exists everywhere. Where a problem like letter A, f of x equals 1 over x, what we have here is we have a potential issue. Because I have the fact that we are dividing by x, think about, before I say this, think about, is there an x value that we could put into the denominator that would cause an issue? Meaning that isn't just an actual number, like 1 over 10 or 1 over 5 or 1 over 3. And if you hopefully think about that, 0 is going to cause a problem there. Because anything divided by 0 is undefined. Meaning it doesn't exist when x is equal to 0. If I plug in the x value of 0, I'll have 1 over 0. That's undefined. I can't do that. So now think, is there any other x values that are going to cause an issue like that? And the answer is no. I could plug in anything else anywhere. So like 1 over -10, 1 over positive 100, 1 over any single number, 1 over -0.5. It doesn't matter. I'm not going to have any other issues. I'm going to have an output of a y value, but at 0. At x equal to 0 is the only part that causes an issue. So the domain then is going to be from -infinity to 0 with a parentheses, because I do not want to include 0 in my domain discussion. And then I'm going to union that with 0 going out towards positive infinity. So let's talk about that a little bit, this notation. So the domain is from -infinity to 0, union with 0 to infinity. The reason I have to break this into two intervals, and it might seem kind of silly, you're like, wait, I'm going up to 0, then I'm going from 0 to infinity. I have parentheses at 0, meaning I'm not including 0. So I'm approaching 0, and then there's a gap, something's happening at 0, and then I'm picking it up on the other side of 0. So I'm going to 0, and then I'm approaching 0, but something is happening at 0. There's a gap there in the graph, there's a hole, there's something going on at 0, and then we'll investigate that a little bit more down the line, but it's called the asymptote at 0. Well, that's not really relevant for right now. We're just trying to understand how to find that domain. So 0 causes an issue. Let's look at letter C. H of x equals 1 over x squared. So in this one, the x value squared, same thing. I mean, there's nothing else that's going to cause issues other than 0, because when x is equal to 0, that's just going to be 1 over 0 squared. 0 squared is 0, so you're just going to end up with 0, but nothing else is going to do that. So same thing, same domain, negative infinity to 0, union with 0 to infinity. We just want all possible values other than 0. Letter D is a little bit different though. 1 over x minus 3. So keeping that same discussion that we just had with 0, if I were to plug in 0, look what happens here. If I were to plug in 0, I get 1 over 0 minus 3, 1 over 0 minus 3, 0 minus 3 is negative 3, 1 over negative 3. That's fine. So, okay, well, that's okay. So 0 works. Just think about, is there an x value though that we could substitute in here that would cause a potential issue? Meaning, is there an x value that will make the denominator 0? Well, if I take x equal to 3, look what happens here. 3 minus 3 is 0. So that's going to be an issue. So the domain, we cannot equal 3. And that's the only x value that's going to cause any sort of problem. So this time, the domain is going to be from negative infinity up to 3, because 3 minus 3 is 0, unioned with the other side of that, 3 to infinity. So same thing as what we just did with negative infinity to 0, but we want to go up to 3, because 3 minus 3 is 0. That is no good. We cannot divide by 0, so 3 is the only value that's going to cause any sort of problem with the domain on that one. And like a linear line like 3x plus 5, that's going to be all real numbers. There's no x value that we could plug in there that's going to get like an undefined answer or some sort of issue going on. So it exists everywhere for letter B, but letter C and D and A, we have to identify those potential issues. Let's look at some graphs identifying domain and range. So given the graph finding domain and range, use interval notation. So on this one, notice how we don't have arrows at the end. Those are actually fixed points. They're just like actual points there, so it stops at there to there. So let's identify the domain, meaning all the x values. So if I'm at x equal to negative 7, let's say I'm out here, are there any y values corresponding on that graph? No. Okay, so I'm not going to be at negative 7. What about negative 6? Well, I have this point. So the domain starts at negative 6. I'm going to use a bracket because I'm going to include negative 6. And then my thought process here is, well, the domain starts at negative 6, and then as I'm going left to right, I am going, so I'm at negative 5, negative 4, I have here 3, 2, negative 1, 0, 1, 2, 3, and then if I'm at 4, I'm nowhere. This graph is not at x equal to 4, so it stops at the x value of 3. So that's going to be from negative 6 to 3 with a bracket. And I'm using brackets because of this filled in circle here. It's the actual endpoint, meaning at 3, we exist at the graph at y equals 2. So I have brackets. Brackets means we're including those points, where parentheses meant we are not including the points. That means I'm getting as close as I possibly can to 0, but not actually including 0. Let's take a look at the range. The range is the y values. So now we're looking at the y-axis. So the y-axis, I am at negative 1. This graph starts at the y value of negative 1 right there. Y value negative 1. So the range starts at negative 1. And for range, we go from bottom to top. So we start at the bottom y value, then we go to the top. So it starts at negative 1, and then as I go along the y-axis, I go all the way up to the y value of 2, because it goes right there. So negative 1 to 2 with brackets. So that was just a line segment. It stops at a point, and it stops at another point. It doesn't go on forever. It just stops, because there's actual endpoints there. Where in letter B, this is a little bit different. We have this parabola here, where it goes through here, and then it goes back up. So let's take a look at the domain. And it got cut off a little bit. There should be some arrows here, meaning it's going to go on forever and ever and ever. So let's talk about the domain. The domain, if I'm going forever and ever and ever, as I'm going out on the x-axis, the x values, this is going to keep going. It's going to go very, very, very slowly, but it is going to keep on going out towards the negative direction. If I were to just zoom this out, like x equals to negative 10,000 or something, this graph would exist, but it's a very, very, very slow, gradual move. But it is going to be out there. So the domain is going to start at negative infinity, because it is going to be out there. It's just going to keep going forever and ever and ever. And as I go along the x-axis, going left to right, I dip down, I go back up, and then this is going to do the same thing. It's going to go out forever and ever, out towards the positive direction. So the domain then is going to be from negative infinity to positive infinity. It goes on forever and ever in both directions. Let's take a look at the range. So the range is the y values. And again, this is going to go on forever and ever. So the range is, where does it start if we're looking at it from bottom to top? It bottoms out here at the y value of negative 2. So I'm going to put a bracket negative 2 because it bottoms out right there. It doesn't exist below negative 2. Sorry, I know I forgot my camera's right there. So it bottoms out at negative 2, and then it goes on up for infinity. Those arrows are just indicating that we're going up forever and ever and ever. So the range is going to go from negative 2 to positive infinity with the parentheses. So I'm negative 2 because I'm capping it off. I'm stopping at negative 2. It bottoms out right at negative 2, but then the range goes up towards positive infinity forever. So domain and range of functions using graphs and just the actual functions. And I know we didn't talk about range on these. We're just really worried about function, but here, domain and range. So hopefully this was okay.